Okay, today we're talking about real zeros of a polynomial function. So our objective really is to find the real zeros of a polynomial function. And today's lesson is going to be a lot of stuff. Okay, so you really want to pay close attention to the little detail and kind of pause and rewind if you need to. Okay, so we'll start with the definitions. You hear the word root and factor and zero all the time, so let's make sure we know what they are. So if you have a polynomial function like this, and say you can factor them or it into these little factors here. So what you have is the x minus 1 is a factor of f of x, right? Because if you can break it down to two little guys, then they're factors. X plus 12 is also a factor. And from that one, what it means is if you take f of x divided by x minus 1, you get x plus 12. So in the long division, which you learned yesterday, it should look like this, right? You take the polynomial, divide by a factor, you get the other factor, whatever's left over. Okay, that means that it goes in evenly. There's no remainder. All right, so from there you get 1 as a root, because 1 is what makes this 0. Okay, so the opposite of this number basically. So 1 is a root of f of x, and what that means is f of that root, f of any root, gives you 0. So if you plug 1 in for your f of x, you get 0. See, so 1 squared plus 11 times 1 minus 12 gives you 0. Or you plug it into the other form, the factored form, you also get 0 because 1 minus 1 is 0, and that's how it works. Okay, for the context of our class, root and 0 have very minor differences that we can ignore, so we can basically use them interchangeably. Okay. In the scope of our class, it doesn't make any difference. Okay, so let's talk about remainder. So there's a theorem, the remainder theorem, that says if f of x is dividing by x minus c, then f of c is the remainder. So let's see what that means. Here is f of x. We're going to find the remainder when f of x is divided by these guys. So if you take f of x and you divide by x minus 3, what is the remainder? Now, if there is no remainder, that means that it divides evenly and x minus 3 is a factor, right? But in this case, let's see if there is a remainder or not. So what you do is you plug in f of this number. So the opposite of negative 3 would be positive 3. So you plug in f of 3 and you get negative 14. So negative 14 is a remainder. What that means is if you divide, you take f of x divided by x minus 3, you get something, and then the remainder is negative 14. So just like yesterday, when you divided, you sometimes had a remainder. In this case, there is a remainder. And you need to understand that that means that x minus 3 is not a factor, because when you divide it, there's a remainder. If it was a factor, f of 3 would have given you 0, just like we talked about earlier. Okay, here's an example for you to try, right? Try to see what the remainder is when you divide it by x plus 2. Okay, what you would do is find f of negative 2. Okay, now let's see if they give you something. How do you know if it's a factor? Well, there's a theorem that says now if x minus c is a factor of f of x, then f of c is equal to 0. That makes sense, right? We just talked about that, where if you find f of c and it's 0, that means there is no remainder when you divide. And when there's no remainder, that means you can divide evenly. That means it is a factor. And the other way is also true. If f of c is equal to 0, then x minus c is a factor. Okay, so let's use that in an example. And we're going to use this to find out what are the zeros of f of x. Here, f of x is a nice trinomial. So it's a quadratic. We know how to factor it. So factoring is the easiest thing to do. I'm just going to factor it. I get my factors to be x minus 6 and x plus 1. Since x minus 6 is a factor, so opposite of negative 6, positive 6 is a 0 or a root of f of x, right? And x plus 1 is also a factor, so negative 1 is a 0 or a root. So what we know is f of 6 gives you 0 and f of negative 1 gives you 0. So here is an example. Um, is x minus 1 a factor of this guy? Okay, if you want to, if it's a factor, you try to find f of this number. So f of 1, is it a 0 or not? If it is a factor, then f of 1 will be 0. So you try that out. I find f of 1. So it gives me all this junk. And ultimately, it gives me 0. So yes, it is a factor. Okay. So you want to know if it's a factor, find f of that whatever x is subtracting. If it's 0, it's a factor. Now, this one for you to try is x plus 2 a factor. What you would do is find f of negative 2 to see if it's equal to 0. Now, there's a theorem that says if you have like a long polynomial like this, any kind of polynomial, any of their rational zeros, okay, any zero that you might have is of this form, okay? So any zero you have, they are given by the factors of the constant term, the last term, divided by the factors of the leading term. Okay, so again, guys, it's kind of important that you try to learn how to read this kind of mathematical definitions, especially if you want to go to calculus next year, right? All this says is if you have this constant times x to the power of whatever, so a polynomial, the rational zeros are the factors of the a0, which is the last term, divided by the factors of the first term. So let's see what that means when we do an example. They want to find all the possible rational zeros of the function here. So you need to find all the factors of negative 6 and all the factors of 2. So all the factors of 6 are, 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. And all the factors of 2 are negative 1, negative 2, and positive 1, positive 2, right? Just the factors, but also their positive and negatives. And then you take each of the top divided by each of the bottom. So like negative 1 over negative 1 is 1. Negative 1 over 1 is positive or negative 1. And I take each of them over each of the other. So it turns out to be a lot, right? Negative 1 over 1, positive 1 over 1, and then negative 2 over 1, positive 2 over 1, negative 3 over 1, positive 3 over 1, and then 6 over 1, negative 6 over 1, 2 over 2, 3 over 2, 6 over 2. So each of the top over each of the bottom. And I know it seems like a lot, but when you get used to it, it will be a lot faster. Once you understand the process, it's going to be a lot faster. And you can skip writing out all of them because you see a lot of these are repeats, right? Like 2 over 2 is just 1 over 1. And negative 2 over 1, 2 is negative 1 over 1. Things like that. And 6 over 2 is like 3 over 1. So a lot of times you will get to a point where you can skip a lot of these. And you jump to the simplified version, which is positive and negative 1, positive negative 2, positive negative 3, positive negative 6, positive negative 2/3, and positive negative 1/2, or 3/2, not 2/3. Okay, so that's how you find the possible rational zeros. So the zeros of these guys has to be one of these, or any of the zero in here got to be part of these guys. Okay, so they can't be anything outside of these guys unless they are irrational, which is something else. We're not going to talk about that. So here we're going to use that theorem and find all the zeros. We're actually going to find them. Okay, so example here, we're going to find all the rational zeros of f of x. Here is f of x. What are the zeros of this guy? Okay, so the degree here is 3. So there's a theorem that says if it's the degree 3, you can't have more than 3 zeros. So the maximum you can have is 3 zeros. Okay, that's something good to know. It's not super important, but we know, oh, I can't have more than 3 zeros for this guy. Okay, so the potential zeros, again, guys, it's all the factors of this over all the factors of this. So all the factors of 12 over all the factors of 1. So the 1 really helps out because there aren't that many combinations left. It's just 12 over 1, 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1, and all the positive and negatives of that, right? So now I have all the potential zeros. I know it's got to be among these guys. I'm going to test each of them until I find them. Okay, so how do I test that? If it's a 0, then I plug that in for x, it's got to give me equal to 0. Okay, if it's a root, it's got to give me 0 when I plug it in. So I'm going to plug in 1. And when I test 1, I plug 1 in for x, I get 4. So that one is not a 0. It's not a factor. It's not a root, right? I'm going to test -1. Ooh, that still doesn't work, right? It gives me 18. Okay, move on to 2. I'm going to test 2. And actually, yeah, that one does give me 0. So 2 is a root of this function. 2 is a 0. And if 2 is a 0, I know that x minus 2 is a factor. What does that mean? X minus 2 is a factor. That means that f of x is equal to x minus 2 times something, right? Because I can factor this, and I get x minus 2 and something here. Then all I got to do is figure out what is this something here, so I can find the zeros of that, and I'll be done, right? So one way to do it is just to divide, right? Take f of x divided by x minus 2. And I'm going to do synthetic division here. So I take f of x, all these numbers, 1, -1, -8, and 12. And I divide by x minus 2, which means I put 2 out here. And I divide that. See, I get 0. It works. When I divide that, I don't have a remainder. That means this guy is the pink guy that is missing here. So the 1, the -6 gives me the polynomial that is left after I divide by x minus 2. So what that means is I get 1x squared plus 1x minus 6. See, that's the pink guy. That's the result after I divide it. Okay, now I got 1 0 from this guy, but I don't know what the zeros are remaining in this guy. So what I can do is, because it's a quadratic, it's nice. I know how to deal with quadratic. I can just factor it. And when I factor that, I get x plus 3, x minus 2. So the zeros from this guy is -3 and +2, right? So ultimately, I have a 2 here and a 2 here. That's why my zeros are 2 with multiplicity of 2, because there are 2 of them. And then -3 with multiplicity of 1, because there's only 1. Let's do one more example, and then we'll be done. Ugh. Just ignore that. That's going to come in later. So here's an example. I have a longer polynomial. I want to find all the zeros, right? So let's look at the potential zeros. By the way, you can have only up to 4 zeros. So if you found 4, you're done. So it's going to be factors of 2 over factors of 6, right? The factors of 2 are positive, -1, positive, -2. The factors of 6 are, these guys, 1, 2, 3, 6. So you just have 1 over 1, 2 over 1, 1 over 2, 2 over 2, 1 over 3, 2 over 3, 1 over 6, 2 over 6, right? And then positive negatives of all of them. So it comes out to be, I have, 1 over 1, and then 1 over 2, 1 over 3, 1 over 6. And then 2 over 1 is just 2. And then 2 over 2 is 1, so it's there already, right? So 2 over 3 is right here. And then 2 over 6 is just 1/3. So these are all the possible ones that I could have. And then I'm going to test them all. And guys, the strategy is this: test the whole numbers first. Don't do the fractions. Fractions are really hard. So do the whole numbers first. Maybe you get lucky and they're one of the whole numbers, so you can move on, right? Don't test the fractions. It's really hard. So I'm going to test 1. Doesn't work. I'm going to test -1. Hey, it works actually, huh? Wow. So if I test -1, it works. That means x plus 1 is a factor. Okay, x plus 1 is a factor. What does that mean? Well, my f of x is equal to x plus 1 times some guy. And I need to find that guy by doing, again, synthetic division. Oh, yeah. So synthetic division gives me, synthetic division gives me the remainder of 0. So this guy gives me what the pink guy is. If I divide, I get the pink guy, right? Take the green divided by the red, I get the pink guy here. So that's 6x cubed minus 13x squared plus 1x plus 2. Now, right now, if you don't know how to do synthetic division, long division, guys, that was yesterday. You needed to learn that, because you can't just leave lessons that we were supposed to do And then if you don't know how to do that, you can't do today's stuff. You see, you can't let them pile on. All right. But anyway, so after I divide it, I get this pink guy. Now I got to break this pink guy down so that I can find the other zeros that are embedded in this guy, right? So I'm going to repeat this. So I'm going to call this pink guy like Q of X or whatever. So I'm going to call Q of X is that guy, and I'm going to repeat the whole process again. I'm going to go back and try these factors again, right? So I'm going to try test 1, does not work. I'm going to test -2. Oh, by the way, you don't test 1 again, right? Because if it failed earlier, it will fail again. So don't test 1 again, okay? That's why I didn't test 1, because 1 failed earlier is not going to work this time. So I'm going to test -1. It worked earlier, it might work again, right? So I'm going to test -1. Although -1 doesn't work, I'm going to test -2. We haven't tried that yet. All right, -2 doesn't work. I'm going to test 2, and 2 works, right? If 2 is a 0, then x minus 2 is a factor. Okay, what does that mean? That means that I break this pink guy down to x minus 2 and some other guy. See, are you guys following this? Every time you find a factor, it means that it's that factor multiplied by something gives you that. So how do you find this yellow guy? You take the pink divided by x minus 2, right? So there it is. I take the long division or synthetic division, 6, -13, 1, and 2 divided by +2, and I get a remainder of 0, so that means I did it right. There's no remainder when I divide. So this guy here gives me what the yellow guy is, right? 6x squared minus x minus 1. So there it is, 6x squared minus x minus 1. And now I got to break this guy down to find the zeros that are stuck in this guy, right? So what I can do here, this guy is a quadratic now. I can factor that. And by the way, you guys really need to work on your factoring, because on the test, we didn't do very well with the factoring problems, okay? You guys just do like quadratic formula, and then you messed all that up. So factoring is easy, is important. Learn how to do that, okay? So here it is. I break that yellow guy down. I factored it. It was like this. I factored it. Now it's like that. Then I have all my zeros, you see? -1, +2, -1/3, +1/2. Okay? Those are my zeros.